Hello, dear students. I hope you are all doing well in this critical situation of COVID-19 pandemic. Follow all health guidelines, stay home, stay safe, and keep studying from your home. In this subject of design of steel structure, first of all, I like to introduce this subject in front of you. First of all, you have to understand what is structural steel. Structural steel is a category of steel used for making construction material in a variety of shapes. Many structural steel shapes take the form of an elongated beam having a profile of a specific cross section. And steel is nothing but iron. Depending upon the chemical composition, mainly depends upon the percentage of carbon characteristics as well as name of iron has changed. Like in which type of iron percentage of carbon is greater than 2, those are called cast iron. Where percentage of carbon is less than 0.15%, those are called wrought iron. A great example of wrought iron is Eiffel Tower. Eiffel Tower is made of 9,000 ton wrought iron. But nowadays, wrought iron is not used as a structural steel. Wrought iron is used for making furniture. The structural steel which are used for construction nowadays, the percentage of carbon on those type of iron is 0.15% to 0.17%. This type of iron is called steel, or we can say structural steel. As this is a subject for designing, so we have to use some Indian standard codes, just like RCC. But in this case, that means in design of steel structure, we have to use different Indian standard code, mainly IS 800 2007 and SP6 Part 1 1964. These two codes are used to design of steel structure. In IS 800 2007, designing procedures, formulas, consideration, these all are given, and SP6 is used to choose the structural steel sections. As we know, for design purpose, generally we are using three types of method: working stress method, limit state method, and ultimate load method. In case of design of steel structure, working stress method and ultimate load method is almost obsolete, because IS 800 2007 introduced 100% limit state method in design of steel structure. As we have to follow IS 800 2007, so we have to follow the design procedure of limit state design. Steel structure have some advantages and some disadvantages. First of all, I like to discuss the advantages of steel structure. First property is lightness. As steel structure is comparatively light, so the members can be conveniently handled and transported. Second advantage is high strength per unit weight of member. Number 3, ductile material. Steel is ductile material, so before failure of any member, a plastic hinge created which indicates the weaker portion, so one can replace it in time. Just imagine a use and throw plastic pen. If you bend the pen, it will create a white plastic hinge. This is a real life example of plastic hinge. Now, number 4, due to having both strain and ductility, steel members subjected to long deformation during fabrication and erection will not fracture. Number 5, if a steel structure or steel members are maintained properly, it will give a long life of structure. Number 6, easy modification. That means addition and alteration can be made easily. As I discussed earlier in point 3, that steel structure is a ductile material. Before failure, it will indicate the weaker portion. So, if we want to alter the weaker member, then to alter this member is very easy for steel structure. Now, number 7, as in a whole structure we use same grade of steel, so quality of the structure will be uniform in every structure. Number 8, non-shrinking and non-creeping at ambient temperature. Shrinkage and creeping property is not applicable for steel structure. These properties are applicable for RCC structures, not for steel. Number 9, the most important, form work not needed for steel structure. Formwork is extra costing for RCC structure, but in this case, in steel structure, no formwork is needed. Now, few disadvantages of steel structure. Number 1, susceptibility to corrosion. Yes, any steel structure, as steel is iron, so corrosion is very common, so we have to take precaution to make it corrosion free. Next, number 2, low fire resistance need fireproof treatment, which increases cost. Next one, number 3, is fatigue of steel is one of the major drawback, and you have to remember this point. And there is another point which is not written here, that is, for steel structure to connect every member, we have to arrange a little bit skilled labor. Now, I want to discuss few of IS codes for design of steel structure. I have already discussed about IS 800 2007, and in number 5 you can see SP6 part 1, that is handbook, that is also called handbook. But there are three other IS codes are used in this design. IS 875 part 1 for dead load, IS 875 part 2 for imposed or live load, IS 875 part 3 for wind load. As structural steel has a few variety of shape, so we have to discuss about the varieties of shapes of rolled steel section. Now, steel structure design is based on appropriate section or cross section for the individual section. This section is called rolled steel section. At left, you can see a I section. This may be rounded like this or maybe sharpened. The different parts of this I section, first of all, let me tell you, this is a cross section of any I section steel member. So these sections, the I, C, the every name is the name of the cross sections. First of all, in I section, we can see there is a upper portion, lower portion, and a middle inclined portion. The upper and lower line portion is called flange. The middle inclined portion is called web. From top of flange to bottom flange is the depth of this I section. Thickness of flange is denoted by T suffix F. Thickness of web is denoted by small t suffix W, and width of flange is denoted by small b suffix F. Now, in right side, you can see a section, the shape is like C. So this section is called rolled steel C section or rolled steel channel section. There is also two flanges at top and bottom and a web. In this case also thickness of flange is denoted by T suffix F and thickness of web denoted by T suffix W. Now in next page left side you can see a two-legged L-shaped section. This section is called rolled steel angle section. Thickness of this section is denoted by T. Width is denoted by B and depth is denoted by D. In right side you can see a T-shaped section. This section is called rolled steel T section. There is a single flange at upper side and at bottom there is a web. Thickness of flange denoted by T suffix F. Thickness of web is denoted by T suffix W. At the lower portion of this page we can see some sections. These sections are called rod, steel, tube section. These are the few shapes of this tube section. Bureau of Indian Standard or Indian Standard Institution standardized steel sections depending upon few materialistic properties. In market, we can get steel members with these names. First, for I section, there are 5 divisions: Indian Standard Junior Beam, ISJB, Indian Standard Light Beam, ISLB, Indian Standard Medium Beam, ISMB, Indian Standard Wide Flange Beam, ISWB, Indian Standard Column Section, ISSC. This junior, light and medium depends upon mainly which properties. In market, these sections is available with depth criteria. Say if we want to buy Indian Standard Medium Beam, that means ISMB, we have to specify the depth of that section also. Now the various depth criteria are also mentioned in SP6 part 1. So if we want to buy ISMB, we have to specify that ISMB 400 or ISMB 450 or ISMB 300. This 400 or 450 or 300, this denotes the depth of that section. It is applicable for I section and C section in both cases. Now for C section or channel section, there is also 5 different types of section is available. First, Indian Standard Gate Channel, ISPG, Indian Standard Junior Channel, ISJC, Indian Standard Light Channel, ISLC, Indian Standard Medium Weight Channel with Sloping Flange, ISMC, Indian Standard Medium Weight Channel with Parallel Flange, ISMCP. These are the types of C sections. If we want a specific C section, suppose ISJC, in this case also we have to specify the depth, but the depths are as per specified in SP6 part 1. Next is angle section. Now angle section is denoted by ISA, Indian Standard Angle. There are 2 types of angle: Indian Standard Equal Angle and Indian Standard Unequal Angle. This equality and unequality is depends upon these 2 legs. If the length of these 2 is same, then it is called Indian Standard Equal Angle, and if the depth is not same, then it is called Indian Standard Unequal Angle. The writing procedure is ISA. Suppose in this picture you can see an example. The leg length is 65, both legs. 65 means 65 mm, and thickness is 8, that means 8 mm. So this section we have to write like this: ISA 65 by 65 by 8. That means 2 legs are 65 and thickness is 8. Suppose one leg is 50 mm, another leg is 75 mm, and thickness is 6 mm. In that case, we may write, we have to write actually Indian Standard Angle, the ISA, 75 by 50 by 6. This denotes one leg is 75 mm, another leg is 50 mm, and the thickness is 8 mm. Now, next part, T section. There are four different type of T section. Indian Standard Rolled Normal T beams, ISNT. Indian Standard Rolled Deep Legged T beams, ISDT. Indian Standard Lightweight T beams, ISLT. Indian Standard Medium Weight T beams, ISMT. So these are the basics of standardized steel section. These are the names of steel section which is available in market and which we have to use in case of design purpose. So that's all for introductory part of design of steel structure subject. Thank you.